sold them. Why do we need to know the end behavior of these polynomials? Well, I'll tell you, it's because when we are drawing just basic sketches, or if we're even graphing more specifically, then we know basically what they look like. And that is really, really helpful. So let's look at an example here. It says, describe the end behavior of the graph f of x. Okay, two things we need to know. We need to know the degree, and we need to know the sign of the leading coefficient. I should say sign of leading coefficient. All right, so we look. The degree is 4, so the degree is even, and the leading coefficient is negative. All right, so I remember back to what we just talked about, and if I'm graphing a general graph, just kind of sketching it, I know that as x approaches positive infinity, it's going to go down, and as x approaches negative infinity, it's going to go down. And it's x to the 4th, so it probably has a little loop in it, okay? So it's basically going to look like that. And give or take. I don't know exactly what it looks like, but that is basically what it's going to look like, and that's what they're after. Okay, so I want you to try this one. So go ahead and pause right now. Okay, so again, two things we need. We need the degree, and we need the leading coefficient. What's going on, okay? So this is in standard form, which is good. So all we have to really do is look at this first term. That's what tells us what we need to know. So the degree is odd, and my leading coefficient is positive. So I know it's going to go in a positive direction, and it's going to look something like this, and it's cubic. So it will look something like that. All right. So now graphing a polynomial is basically what we were just doing, only we need to plot more specific points. So here's just the steps. Look at the degree and the leading coefficient to get a general idea of what it looks like. Okay, plot 3 to 6 points and then make a smooth line. You're just plotting points, really. So I look at this. My degree is 3. And my leading coefficient, you know what I should say, instead of saying 3, I should say negative. Not negative, odd. And my leading coefficient is negative. So it is basically, if it's negative and it's odd, it's basically going to look something like that. Okay, so I know that my end, describing the end is going to be like this. Okay, the behavior of the ends. All right, so now let's plot some points. And I actually used my graphing calculator for this. If you have a graphing calculator and you would like me to show you how to do this, I can show you how to do that. It'll plot the points for you. So -2, 3, -1, -4, 0, -3, 1, 0, and 2, -1. So now I'm just going to come over here and plot these. So -2, 3, -1, 4, oh, -4, I was going to say, 0, -3, 1, 0, and 2, -1. Okay, right now it just looks kind of like a blob, all right? But I know that it's basically going to look like this. I don't know how far down it goes or anything like that. I just know that chances are this is going to keep going on this way, and this is probably going to keep going on this way, and it's going to connect something like that, okay? And so this would be graphing a polynomial. Now sketching a polynomial is a little different. This is when we don't really need to know the exact points. And this can be a little bit tricky. So this one we're gonna look at a little more slowly, a little bit more step by step. Okay, so sketch a graph of the polynomial function f having these characteristics. And actually, I'm going to do this in the next video because this is going to take a little bit more time. So I will do that in the next video.